Hello everybody. In this video we are going to be looking at the solutions to the Physics 1 Transformer Worksheet. Is this a Transformer Worksheet or is this called Transformer Practice Problems? I'm doing so many of these things I'm getting confused. Hold on for a second. Alright, I'm back. It's the Transformer Worksheet. Just had to double check. So there's a few of these. There's a lot of information in each one of them. Let's start with the first problem. We are given a diagram of a transformer and we are given some values and we are looking to fill in the table for the rest of the values. So we're given a table that shows us the voltage, the current, the number of coils, and the power for the primary and secondary coils. In this problem, we're given the voltage on the primary coil is 120 volts. The current on the primary coil is 20 amps, and the number of coils on the primary coil is 30 coils, and on the secondary coil it is 600. The first thing that we should find on this problem is the voltage of the secondary coil. So to do that, we're going to use our transformer formula, and I know that the ratio of the secondary voltage to the primary voltage is equal to the ratio between the secondary coils and the primary coils. I am going to solve this for the secondary voltage by cross multiplying and then dividing both sides by N sub P. When I do that, I get Vs equals Ns times Vp divided by Np. I plug my known values into that equation, and I'm going to get a voltage on the secondary coil of 2400 volts. The next thing we want to find is the current on the secondary coil. We're going to do the same thing, but we are going to use the formula for current. And again, we are going to simply cross multiply here. And when we do that cross multiplication and we solve for the current on the secondary coil, I'm going to get Is equals Np times Ip divided by Ns. And when I do that math out, I'm going to get a current on the secondary coil of 1 amp. To find the power on the primary and secondary coil, I simply have to multiply the current and the voltage of each of those coils. So to get the power on the primary coil, I multiply the current of the primary coil by the voltage of the primary coil. 20 amps times 120 volts equals 2400 watts. And to calculate the power coming off of the secondary coil, I multiply the current of the secondary coil by the voltage of the secondary coil. 1 amp times 2400 volts is going to equal 2400 watts. Note that these two values are the same. They always should be. The power going into the transformer should always equal the power coming out of the transformer. We're changing the voltage and the current up and down, but the power should remain the same. And the last thing that they want us to find in this problem is they're going to ask, is this a step up or a step down transformer? Because let me change color here. Because my secondary voltage is greater than my primary voltage, I'm stepping up the voltage from primary to secondary. This is a step up transformer. Problem number 3. A transformer has a primary coil with 200 turns and a secondary coil with 2000 turns. The input voltage is 120 volts and it runs at 1800 watts. Fill in the table below. So we are given the primary voltage of 120 volts, the number of coils on the primary side of the transformer, which is 200, the number of coils on the secondary side of the transformer, 2000. We are given the power going into the primary coil, 1800 watts. The first thing that we should find is the voltage coming off of the secondary coil. And to do that, I'm going to use my ratio of voltage and number of coils. So I know that the ratio of the voltage of the secondary coil to the voltage of the primary coil equals the ratio of the number of turns on the secondary coil to the number of turns on the primary coil. Once again, we are going to cross multiply and solve for the voltage on the secondary coil. When I do that, I will have Vs equals Ns times Vp divided by Np. Doing my math out is going to give me a voltage of the secondary coil of 1,200 volts. To find the current on the primary coil, I could use the ratio, but I also know that the power is equal to the current times the voltage, and I know the power on the primary coil, I know the voltage on the primary coil, so now I can find the current on the primary coil. So the current of the primary coil is equal to the power of the primary coil divided by the voltage of the primary coil. 1800 watts divided by 120 volts is equal to 15 amps. Could have also used the ratio formula to find that. I thought the math for this one was a little bit easier, so I decided to use this formula instead. Could have used the other one, and it would have come out the same either way if I wanted to find the current on the secondary coil first. So now I want to find the current on the secondary coil. To do that, I will use my ratios. So I know that the ratio of the current on the secondary coil to the current on the primary coil is equal to the number of turns on the primary coil compared to the number of turns on the secondary coil. Once again, we cross multiply, solve for the current on the secondary coil, and I'm going to have the current of the secondary coil is equal to the number of turns on the primary coil times the current of the primary coil divided by the number of turns on the secondary coil. When I do that math out, I'm going to have a current on the secondary coil of 1.5 amps. To find the power of the secondary coil, I know that that's going to equal the current of the secondary coil times the voltage of the secondary coil. 1.5 amps times 1200 volts is going to equal 1800 watts, which is going to be the same as the power going into the primary coil. So I know I did that right. The last thing that they want us to find out is this a step up or step down transformer? And once again, my secondary voltage is greater than my primary voltage, so I am increasing the voltage from the primary to the secondary coils, which makes this a step up transformer. One last note before we end this portion of the video. One thing I did want to point out to you is, and let me just make some erasures here just to unclutter this here. Thank you very much. One thing I do want to point out is that if you look at the number of coils, it increases by a factor of 10. I go from 200 coils to 2,000 coils, so that increases by a factor of 10. Because all of this is proportional, if my number of coils increases by a factor of 10, then my voltage has to increase by a factor of 10 as well. And I do. I go from 120 volts to 1200 volts because my voltage and the number of coils are directly proportional to one another. And lastly, if my number of coils increases by a factor of 10, that means, and let me just do a couple of erasers here, that means that my current has to decrease by a factor of 10 as well. And we notice that my current goes from 15 amps to 1.5 amps. So my current is decreasing by a factor of 10 because it is inversely proportional to the number of coils. Problem number 5. A transformer has a primary coil with 100 turns and 35 amps, and the secondary coil has 150 turns. The power in the secondary coil is 1.4 kilowatts, and they want us to find the rest of the values. So in my primary coil, I know I have a current of 35 amps and 100 turns. In my secondary coil, I know I have 150 turns and 1.4 kilowatts of power. Because I know the number of coils in both the primary and secondary side of the transformer, and I have the current on the primary side, I'm going to start out by finding the current on the secondary coil. So again, I'm going to use my ratio for the current. I am going to cross multiply, as always, to find the current on the secondary coil. And I know that the current on the secondary coil is equal to the number of turns on the primary coil times the current on the primary coil divided by the number of turns on the secondary coil. I plug my known values into that equation, and I'm going to get a secondary current of 23.3 amps. Let's just call that 23 amps, even though we're not really worried about significant figures in these problems. Now I know the voltage, I know the current and the power on the secondary coil. I can find the voltage on the secondary coil using P equals IV. So solving that for the voltage, I know the voltage of the secondary coil is equal to the power on the secondary coil divided by the current on the secondary coil. So 1400 watts divided by 23.3 amps is going to give me a voltage of 60 volts on the secondary coil. To find the voltage on the primary coil, again, there's a number of ways you can do this. You can do them in different orders. You could use different equations. There's multiple ways of doing it. This is just the way that I'm doing it because it makes sense to me, and I'm just using what I know for certain at this point. So to find the voltage on the primary coil, I'm going to use my ratio of voltage and number of coils. And again, we will cross multiply and solve for the voltage of the primary coil. When I do that, I know that the voltage on the primary coil is equal to the number of turns on the primary coil times the voltage of the secondary coil divided by the number of turns on the secondary coil. When I do that math out, I'm going to get a primary voltage of 40 volts. And to find the power on the primary coil, again, I'm going to multiply the current of the primary coil times the voltage of the primary coil. 35 amps times 40 volts is equal to 1400 watts. And again, my power remains constant on the primary and secondary sides of the transformer. To find out if this is a step up or step down transformer, once again, we will look at the voltage. And the voltage increases from primary to secondary coils. So that tells me this is going to be a step-up transformer. Problem 7. A transformer has an output voltage of 40 volts and an output current of 5 amps. The input current is 0.25 amps and the primary coil has 50 turns. Fill in the table below for this transformer. So on the primary side of the transformer, we are given the current, 0.25 amps, and the number of coils, which is 50. On the secondary side of the transformer, we are given the voltage, 40 volts, and the current of 5 amps. So I know the current on both sides of the transformer. I can use that to find the number of coils on the secondary side of the transformer. So I'm going to use the ratio of current and number of turns on the transformer. And again, I am going to cross multiply, solve for my unknown, which is the number of turns on the secondary coil. When I do that, I know that NS is equal to NP times IP divided by IS. Plug my known values into that equation, and I'm going to get 2.5 turns on the secondary coil. Now I know the number of turns on both the primary and secondary coils. I can calculate the voltage of the primary coil. To do that, I will use the ratio of voltage and number of coils. As always, cross multiply and solve for the voltage of the primary coil. When I do that, I'm going to have VP equals NP times VS divided by NS. Plug my known values into that equation, and I'm going to get a voltage on the primary coil of 800 volts. The last thing we need to find is the power for the primary and the secondary side. We know they should come out to be the same, but let's do them both out mathematically just to be certain. It's a good way for us to check our work. To find the power on the primary coil, I need to multiply the current of the primary coil times the voltage of the primary coil. 0.25 amps times 800 volts is equal to 200 watts. To find the power on the secondary coil, I multiply the current of the secondary coil times the voltage of the secondary coil. 5 amps times 40 volts is going to equal 200 watts as well. So they are both the same. That tells me that I did my math out correctly. Once again, they want us to determine, is this a step up or a step down transformer? So when I look at the voltages here on the primary and the secondary side, I can see that the secondary voltage is less than the primary voltage. So the voltage decreases from the primary to the secondary side. That tells me that this is a step down transformer. Okay, last problem. 180 volts goes into 300 coils. 270 volts comes out of the transformer. The power is 7.2 kilowatts, and they want us to find the remaining values. I know on the primary side of the transformer, my voltage is 180 volts. I have 300 coils, and the power going into the transformer is 7.2 kilowatts. On the secondary side of the transformer, my voltage is 270 volts, and I also have 7.2 kilowatts. Because I know the voltage on both the primary and secondary sides of the transformer, and I have the number of coils on the primary side, I can use my ratio of voltage to the number of coils to find the number of coils on the secondary side of the transformer. Once again, I am going to cross multiply and solve for the number of coils on the secondary side of the transformer. When I do that, I have NS equals NP times VS divided by VP. I plug my known values into that equation, and I have 450 turns on the secondary side of the transformer. Now, I don't have the current on either the primary or secondary sides of the transformer, so I can't use my ratios to find either of those. But because I know the power on both sides and I know the voltages on both sides of the transformer, I can use P equals IV to find the current on the primary and secondary sides. So let's start with the primary side of the transformer. I know that the current on the primary side of the transformer is equal to the power of the primary side divided by the voltage on the primary side of the transformer. 7,200 watts divided by 180 volts is going to give me a current of 40 amps on the primary side of the transformer. For the secondary side of the transformer, I know that 7,200 watts divided by 270 volts, which is the voltage on the secondary side of the transformer, is going to give me a current of 26.6 amps, which I'll round to 27 amps. Lastly, we just need to determine if this is a step up or a step down transformer. Again, look at our voltages. My secondary voltage is greater than my primary voltage, which tells me that this is going to be a step up transformer.